Hello, algebra classes. Today we're going to take a look at another lesson in 9.6. We're going to be working on 9.6e, where we're going to solve quadratic equations using the most efficient method. So we have studied at length the 5 different methods that can be used to solve a quadratic equation. And so we're going to focus on the 3 easiest most efficient methods of solving a quadratic equation. That means we will not be using graphing or completing the square. Those tend to be techniques to solve a quadratic equation that won't be the most efficient. The 3 easiest and most efficient methods to solve a quadratic equation are factoring when it works, taking the square root when it works, and when those 2 easier methods don't work, then we jump to the quadratic formula typically. The quadratic formula can actually be used to solve any quadratic equation, but if you can factor or take the square root, it typically makes it easier to solve that equation. So let's take a look at some specific examples and see how this works. Guided practice A asks us to solve this equation, x squared minus 11x plus 24 equals 0. And this one, in fact, factors using just typical quadratic factoring techniques. It factors into x minus 8 times x minus 3 equals 0. There's my x method, so that I can see where that came from. And because that quadratic factoring worked, I'm going to use that zero product, setting each of my factors that I have written here equal to 0, and that gives me solutions of x equals 8 or 3. So if factoring works, and it does on A, it's a really good and easy technique that you can use to solve a quadratic equation. Let's take a look at B. B will be another equation that we can use to see how factoring can easily solve a quadratic equation. 6x squared equals 12x. So I'm asking myself, can I rewrite this equal to 0 and use factoring? And the answer is yes. Now keep in mind that when you are using factoring as a technique to solve any quadratic equation, you must be equal to 0. You have to be equal to 0 so that once you factor that equation, all of your factors can be set equal to 0, and you can use that zero product property to solve the equation. So that's why on B, since I'm not already equal to 0, I rewrite the equation so I am equal to 0 by subtracting 12x on both sides. Now I'm noticing that greatest common factoring will work for this equation, and so I'm going to factor out a 6x, leaving me with x minus 2 inside, because 6x times x is 6x squared, and 6x times negative 2 is negative 12x. And then I'm rewriting the equation, just simply putting parentheses around the 6x to remind me that I have 2 factors equal to 0, so I may use the zero product property now, setting each of those factors equal to 0, and solving both of those equations so that I know that x equals 0 or 2 solves this quadratic equation. All right, so on A and B, we use 2 different factoring techniques because they worked. On part C, guided practice C, we're actually going to use factoring again, and we're going to use both of those techniques in the same equation because it will work. We're already equal to 0, so we're asking, is there any greatest common factoring we can do? We always want to check that first, because if it works, it is a very helpful technique to solving our equation. So we factor out a 5, leaving us with x squared minus 2x minus 3, because 5 times x squared is 5x squared. 5 times negative 2x is negative 10x, and 5 times negative 3 is negative 15. My next step will be dividing both sides by 5, and that gets rid of that 5, so to speak, and we're left with x squared minus 2x minus 3 equals 0. Using my quadratic factoring techniques, I'm going to rewrite this as the product of 2 binomials, x minus 3 times x plus 1, and you can see my x work here, so you understand where this came from. Then I'm going to set each of those factors equal to 0, and I arrive at the solution x equals 3 or x equals negative 1. So when factoring works, either using greatest common factoring or quadratic factoring techniques or both, it's a great, easy method to solve a quadratic equation. However, factoring doesn't always work. And so part D, we're going to see a situation where factoring won't be the most efficient method to solve our quadratic equation. We notice we have only x squared and no x's. Whenever you have just x squareds and no x's, taking the square root is an excellent option to solve your quadratic equation quite efficiently. On A, B, and C, we had x squareds and x terms, and so taking the square root would not have worked. In this case, it will work easily. First, divide both sides by 4. X squared is equal to 25. Then take the square root of both sides, noticing that you're going to get both a positive and a negative root, and x is equal to a positive or negative 5. We didn't need a calculator on this one because this was a perfect square. Okay, E. Again, I see an x squared term, so all the stuff in here, squared, is your x squared term. And so I'm going to use taking the square root again to solve this quadratic equation. I want to isolate my squared term and then take the square root. So I'm going to subtract 8 on both sides as a first step. And that gives me x minus 2 quantity squared is 12. Take the square root of both sides. Get x minus 2 is equal to positive or negative root 12. Add 2 to both sides, and here's our value of x. It is 2 plus or minus the square root of 12. Split this into two separate calculations to work out. Use your calculator to work out what the square root of 12 is. And then add 2 to 3.46, which is the approximation for the square root of 12. And then subtract 3.46 from 2. Again, there's your approximation of the square root of 12. You're using your calculator to get that result. And then finally, your final answer will be x is equal to 5.46 or negative 1.46. So on the first 4 problems, we either used factoring or taking the square root. We're going to recognize that if we're equal to 0, factoring might be a really good choice. Or if we can get equal to 0, factoring might be a good choice. Typically, factoring, when it works, there will be x squared in x terms, often, but not always. Taking the square root will only work if you just have x squared terms and no x terms. All right, how about this one, letter F? Well, it looks like one of these equations equal to 0 that we can try factoring. But when we try our quadratic factoring, it doesn't work. And there is no greatest common factor to x squared minus 5x and minus 7. The greatest common factor would be 1. So factoring isn't going to work here. What about taking the square root? Well, that won't work either because we have both x squared and we have a negative 5x term. So if we were to add 5x and 7 to both sides to get x squared by itself, and then we were to take the square root, that would tie up this x term in the radical, and we wouldn't be able to solve for x. So that's why when you have x squared and x terms, taking the square root won't work. Well, factoring doesn't work here. Taking the square root doesn't work, so let's use the quadratic formula. So here I am working this out using the quadratic formula. I simply rewrote the equation down here just to have it all in one place. So there's my quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Here I am pulling off my a, my b, and my c, plugging a, b, and c numbers in to this quadratic formula, and I have x is equal to 5 plus or minus the square root of, in parentheses, negative 5 quantity squared. Because b is a negative number, we must put that negative 5 in parentheses to show that we're squaring the negative 5, not just positive 5. Okay, so minus 4 times 1 times negative 7 all over 2 times 1. And now we're going to simplify that. 2 times 1 is 2. Negative 5 squared is 25, and 4 times 1 times 7 is 28. We have a negative and a minus sign, so together that's going to be plus. If you have an even number of minus and negative signs, it's plus. If you have an odd number of negative and minus signs, it would be minus. Okay, so now we simplify 25 plus 28, and we have 53. And then we're going to split this into the two separate calculations that it is. 5 plus root 53 over 2, 5 minus root 53 over 2. Then we're going to use our calculator to find out the approximation for the square root of 53. We'll work out these two calculations separately, and we'll arrive at x is equal to 6.14 or negative 1.14. That concludes all of our guided practice problems for this lesson. So remember, for this lesson, the whole point of what we're doing now is figuring out the most efficient method of the 3 easier methods to solve a quadratic equation. Remember, when factoring, either greatest common factoring or quadratic factoring works, you're going to want to use it to solve a quadratic equation. If it doesn't work, you're going to think about whether or not taking the square root works, and that works beautifully when you have just x squared but no x terms. If neither factoring or taking the square root works, then you're going to want to jump to the quadratic formula to use that to solve your quadratic equation. Don't use completing the square or graphing for this lesson because they aren't the most efficient methods. All right, so now it's time for you to turn to the independent problems in your homework and see if you can work through those, referring back to these guided practice problems as necessary. And we'll see you next time.